Hello and welcome to the Data Engineering Podcast, the show about modern data management. What are the pieces of advice that you wish you had received early in your career of data engineering? If you hand a book to a new data engineer, what wisdom would you add to it? I'm working with O'Reilly on a project to collect the 97 things that every data engineer should know, and I need your help. Go to dataengineeringpodcast.com/97things to add your voice and share your hard-earned expertise. And when you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode, that's Linode, today and get a $60 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. You listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For more opportunities to stay up to date, gain new skills, and learn from your peers, there are a growing number of virtual events that you can attend from the comfort and safety of your home. Go to dataengineeringpodcast.com/conferences to check out the upcoming events being offered by our partners and get registered today. Your host is Tobias Macy, and today I'm interviewing Eldad Farkash about Firebolt, a cloud data warehouse optimized for speed and elasticity on structured and semi-structured data. So Eldad, can you start by introducing yourself?
Yes, hi there. Hi, everyone. Thanks for having me. My name is Eldad Farkash. I'm the CEO and co-founder of Firebolt. I've been with data for around 26 years, started really young, and then kept going with it. Luckily, it's been growing and getting more interesting over the years. So me and data go since I was 16.
And do you remember how you first got involved with data management?
So I've been actually building startups, like 4 startups on data management after my first job on data. So my first job was system integration, was a long time ago. Data warehousing was pretty new. So it was mostly around plugging in cables and connecting things. But again, things changed dramatically. Over the years, I've built a few startups. I think the most kind of famous one is Sisense. It's a business intelligence company. It's a big company now called a unicorn. Been there for 15 years, was serving as the CTO of the company and left 2 years ago to start Firebolt and focus on what I think is more interesting going forward, which is how and where the data is stored and computed.
And so can you describe a bit more about what Firebolt is and your motivation for building it and turning it into a business?
So yes, I've been with high performance computing for my entire career. Since it began as a database company, as an HPC company, we quickly realized that nobody will buy a database from us. So we pivoted the company into a BI tool that wraps technology within it and allows people to build fast dashboards. Now, this was 15 years ago. Over those 15 years, in-memory computing eventually it became something that cannot be used to store and hold the data. And came to realize that my passion is really with the database, the data warehouse, and less with the BI. So I've decided 2 years ago that it's time to kind of refocus and rethink how data warehouses work and kind of tackle the one big problem that I see with data warehousing, which is efficiency and speed. So that's kind of how I've decided to start a new journey and go with my poor startup, build a new data warehouse.
The data warehouse space has been around for a number of years now. It's gone through a number of different evolutions where it started off as big on-premises appliances or just using some of the existing relational database engines on a dedicated box and has now moved to data lakes and cloud data warehouses. I'm wondering if you can give a bit of comparison of how Firebolt sits in that overall space, particularly in reference to some of the more recent versions of the data warehouse paradigm.
Yes. So as you mentioned, kind of there's an evolution going on. Data warehousing started offline, on-premise. Then with Redshift kind of was the first time we moved kind of the same concept, but to a managed environment on the cloud. And then came Athena, BigQuery, which gave us kind of a serverless experience. We moved from managing resources to paying per data scan. And then came Snowflake and gave us elasticity, true elasticity, isolated elasticity, decoupling storage and compute. And that's kind of where Firebolt starts. So Firebolt assumes elasticity to be a core kind of feature of a data warehouse. So you cannot build a new data warehouse without having that core isolated elasticity baked in. But kind of the mission of Firebolt, the challenge of Firebolt was to get the same elasticity without losing speed and efficiency. So for that, we had to change a lot of stuff and pretty much re-architect almost everything throughout the data value chain in the data warehouse. But evolutionally wise, Firebolt starts where Snowflake ends.
Because of the fact that you have such a strong emphasis on performance and reducing the amount of movement for the data that's necessary, what are some of the unique capabilities or use cases that it unlocks?
So there are two big use cases. One is self-service in-house analytics. So the typical dashboarding, BI tools, business analysts writing SQL, whether by hand or through the BI tool. And they want to run those SQL on bigger data, more granular data. So move from pulling data into the BI tool to running the BI tool directly on the data warehouse. And even though this has been kind of discussed for many years, if you look actually today at how data warehousing is being applied, you rarely see that. So in many cases, you're still having people moving data into the warehouse just to move it out back into some in-memory system to get speed up. So the first use case is self-service. The second use case is customer-facing. So data serves your actual product, your actual business. When someone clicks on your web app, it runs an actual SQL query on an actual table and returns results in real time. So those are two extremes, but those two extremes are at their core dependent on speed and efficiency. So with the first, it's more about what happens after the data has been kind of downloaded from the lake or scanned from the lake. So everything that happens between your memory and your CPU. And the second thing is mostly around how do I scan petabytes, hundreds of terabytes of data on my lake and support high frequency, highly concurrent, low latency environment. So I would say on one extreme, you have a Redshift and a Snowflake doing the more traditional BI. And on the other extreme, you have the Athena and the BigQuery and the Druids of the world, which try to tackle real-time, ingest, aggregate, kind of for actual production level scenarios. So Firebolt looks at both extremes as just two ends of the same need. Data goes through different phases used by different people, but being able to crunch the same data internally and then open up the data externally should be kind of should happen in one product and in one experience. So Firebolt is about consolidating ELT analytics and customer-facing apps into one solution.
And one of the other big dichotomies between data warehouses and data lakes is the fact that data lakes are intended for being able to use a variety of different tools and computational methods on the underlying data, but at the same time, it increases the amount of complexity and the number of moving pieces necessary to be able to get a complete solution out of it. And so there has been this blurring between the data warehouse and the data lake with the advent of cloud data warehouses. So I'm wondering what the perspective is for Firebolt on where it lies on that continuum and the ability of people to be able to bring a variety of different tools to interact with the data that Firebolt is managing.
So let's talk a bit about kind of data lakes, data warehouses, a bit of difference between them and why they both coexist today. So first, of course, when it comes to big data, there's always things happening. There's always multiple kind of perceptions or philosophies that are being taken to tackle data challenges. Mostly those approaches stem from who you are. So if you're a heavy data engineering team with a strong engineering background and programming would be your first choice for anything, then you would kind of favor interoperability. You would favor working with multiple databases, multiple tools, multiple environments. So you would want your data lake to be as open as possible, supporting multiple formats, etc., etc., etc. And then there's another thing. There's another market. There's another type of people who come more from the business aspect. They're more business analysts. And today it's very blurred, those kind of things, but this type of mindset says that we shouldn't work so hard to get the data work for us. We should use tools that simplify it, that abstract it, that allow me to ignore how the lake works and focus on writing SQL. So, and of course, this is an evolution, and we've seen a lot of products over the years. So, lots of different kind of approaches. I would say the biggest giants today, each with its own philosophy, would be Databricks and Snowflake. So, Databricks is more about engineering, a lot of tools, a lot of moving parts. You need to understand what merging is, and you need to understand how to work Spark, and you manage resources, etc. Whereas Snowflake does a lot of that, but with SQL. So it's more of a kind of, you rent the warehouse and you have everything much simpler served for you. And I think that the beauty of Snowflake is that they prove everyone that SQL is the way to operate data, and that with the right platform, people who never imagined they can work big data can now work big data. Of course, Snowflake has other disadvantages, but this huge credit goes to Snowflake. They, I think, changed the market and got the data warehousing, or in SQL-driven data warehousing, back to the kind of to the discussion of how to build data-driven solutions. So ELT is kind of because of Redshifts and Snowflakes and BigQueries. I mean, people run their ELT on the warehouse or they run it on Spark. So I think the market will kind of converge into those two extremes. There will be people who will still want to have this extremely open environment, and there will be people who want to have a kind of more simplified environment in which you just get the work done, each with its own advantages. But I think mostly it's about who's using it, what's kind of the technical background of the company. Now, the biggest change we've seen over the last 2 years is that the first group of engineering, kind of the engineering mindset, is starting to realize that they actually like using SQL to run complex data tasks. So it will be interesting to see in the upcoming years how that plays, and I hope that Firebolt will help to push that forward and convince heavy engineering teams that yes, it can be done without kind of understanding how files are stored in Parquet, etc. Now, in terms of the data lake is I think it's nothing new. I mean, data lakes existed forever. We just called them in different names. Beginning, we called them storage devices and shared storage devices, and then they evolved, and then we had Hadoop and we had HDFS. But I think the biggest change and the really thing that made a data lake what it is today is S3. So to me, S3, and of course the equivalent of S3 on other cloud vendors, but S3 was the first platform technology, storage infrastructure that gave us infinite scale, super simple, super cheap costs, which changed everything. And Snowflake proved the world that S3 can be used as kind of this default standard storage mechanism. So the data lake today is mostly about S3 enabling the data lake to be what it is. And I am absolutely certain that S3 and the competition of S3 will evolve, and we'll see new amazing things, giving us more speed with more scale. But the thing for me about data lakes is that they solve problems that data warehouses were trying to solve before. So a data warehouse was mostly about warehousing. Now with data lake, warehousing is something we can decouple and let the cloud vendor do for us. So that's kind of the first big change between data warehousing and data lakes. But if you look today at the data warehouse, modern cloud native data warehouses, then they fully exploit the lake. So they operate on the lake. At Firebolt, we call ourselves a data compute platform that speaks SQL on your lake. But it's just yet another definition for the ability to decouple storage and compute. And there are multiple variations to that. We use kind of the modern elasticity resource isolation approach. So a data lake is here to stay. A data lake will allow us to scan a lot of data, but it's just storage. So it's just the beginning of the journey. Now, the second thing that is very common with and differentiates between the lake and the data warehouse is the format. So the data format. With the data lake, people mostly relate the lake to the ability to use open formats, even though format is really not dependent on the lake, but still people perceive data lakes as, oh, this is the place where I store my Parquet and Avro and JSON files, depending kind of on the need. But in reality, those file formats are extremely inefficient when it comes to read-intensive analytics. So when those formats were invented, interoperability between big data platforms was kind of the bottleneck. So when Parquet came, it solved a big issue. But if you look today, I mean, no matter what data pipeline you build, no matter what technology you use, if you always end up with some sort of a data warehouse running your queries. So it can be an Athena running directly on a Parquet, or it can be Redshift, which uses its own proprietary format, or a BigQuery or a Snowflake. But kind of the things that differentiates clearly between the warehouse and the lake is that the warehouse vendors use their own formats for a very, very good reason, because the warehouse is where you end up your data with, and this is where you want to query your data. And querying means read intensive, lots of users, and this is where we need to change the format and look at how data is stored on the lake differently. And this is kind of one of the big changes that Firebolt brings, is that we first introduce a new format, and this format is sitting, and stored just like Parquet on your lake, and we'll touch that a bit later. But the format and everything on top of that is designed for read-intensive querying. Versus interoperability and having that format support as many platforms as possible. Instead of using the format, we use SQL as our kind of interoperability layer. And with SQL, we can support everything from BI to ELT to kind of data science. So instead of focusing on data formats, we focus on data formats that give us the edge we need for the problems we want to solve. That's it in a nutshell on data lakes versus data warehouses. I think both will blend. And I think if you look at kind of data lake players, they already come out with their own compute engines, and they already realize that they would need probably less moving parts in their systems because it's just evolving, and we solve previous problems. We just don't need that anymore. So I think the data lake is very much like an HDFS period where we love that, we use that, but eventually it will become yet just another storage there.
Yeah, and there's a term that's come out recently of the data lake house, which makes it all sound very tranquil and pleasant. But
and that's exactly kind of, and that's, I mean, I love marketing and I love product marketing, and I think it's in our space. Specifically in our space, it's actually needed because there's so many different technologies and mindsets and ways to solve things. And we're always working on something that was built before. And you never have the privilege to kind of restart everything. So being respectful to what's running now and connecting to it and supporting it is kind of a necessity. You can't just start from scratch. And this is why the lake will continue to be there. And this is why companies will use the lake within their products. But by the end of the day, it's all about abstracting your lake away. So yes, a lake house is basically compute or a file merge process that happens on your lake. Redshift and Snowflake will just not call it that. They'll just hide it somewhere internally.
One of the other aspects of the difference between data warehouses and data lakes is in how you think about structuring and modeling your data, because for some of the batch compute engines or for things like Presto, you want to work with your data in a way so that it's partitioned, so that you limit the amount of scanning that's necessary, and so that it's easier to be able to do compaction operations and, insert tombstones for any deletions so that you can process those in your batch updates. But then in data warehouses, you want to structure it in a way to optimize for the query patterns of SQL and being able to join across dimensional tables and fact tables, and you've got data vaults or star schemas. So I'm wondering, because of the fact that Firebolt is so focused on extreme performance and very fast scans across large volumes of data, how that impacts the way that users should be thinking about modeling their data as it's being loaded into Firebolt and as they're processing it and building out the transformations within the warehouse.
Okay, so first, there is semi-structured and structured, and they can coexist. So actually, with Firebolt, we fully support semi-structured data, both on kind of the storage and on the querying side. Now, let's kind of talk a bit about semi-structured. Semi-structured today exists in two variations. The first one is you have semi-structured support, usually with array types. and the data warehouse vendor or the file format allows you to store primitive types as arrays within your table. The second thing is how you query those arrays. And this is where the big kind of differences are becoming more relevant. And most data warehouses today will force you to flatten the data. And this is why in many cases, even though you have amazing array manipulation support specifically for Presto, and we'll talk about that, people still flatten the data. They still explode the data because it's just too slow. So even though you have array support within your table, within your database as a primitive type, you're still not using it to query in real time. You'll flatten it. And the flattening process removes the whole value of arrays. So Firebolt takes a different approach here. We want to enjoy both worlds. We want to support native array types and multi-nested array types, so you can do many arrays in each other, you nest them together, but we don't want users to flatten the data. We want users to apply array manipulation language, so it's an extension to SQL, which was taken from the Presto standard, but we want that to run extremely fast. If you do that, you get two advantages. One is you keep your table smaller because you don't need to flatten it in advance. You have your table and you have some of your fields as arrays, but then when you query the data and you apply array manipulation within SQL, you want to execute that in a completely different way than you would do with relational operators. So for that, this is kind of where you enter the domain of LLVM, just-in-time compilation, and similar stuff. And this is why Firebolt, by the way, combines vectorization and LLVM just-in-time compilation to support different variations of SQL use cases, even though those would look to the user as just two things that are part of the same query. Now, I haven't mentioned it before, but when it comes to Firebolt, there are two big things. There is storage and there's compute. And we've discussed elasticity. So with Firebolt, you have this concept of engines. Engines are isolated clusters, isolated compute resources. You can have one or many engines running concurrently on the same database. So a database is just a logical representation of your schema. And within those engines, you have the local cache, which stores intermediate data. So you don't have to scan data from S3, etc. But when it comes to storage, it's all about pruning. So indexing your data means that Firebolt, for the first time, orders your data when you ingest it. If we can order the data, and if we can do that fast enough, then we can completely change the way we build query engines and basically change the way we build indexes and change most of the way data warehouses work. And clustering and sorting and ordering has been a huge pain for data warehouses over the years. And even today, it's not actually working. So most companies will not apply clustering because it's just reordering the data in the background and it costs huge amounts of money. It doesn't work. In order to make ordering of data work, you need to do that through ingest. And if you get that right, if you get your data coming in a natural order and coming out in an sorted order, then amazing things start to happen. So Firebolt introduces a primary index on your table, meaning you can have 1 or 100 columns defined as your primary index. This means two things. One is we sort the data by this compound index. So each chunk we generate, a file or a set of files, we can call it, will be ordered by this index. Now, as data gets streamed in and gets ordered and stored as ordered files and uploaded to S3 and committed to S3, we also index the data. Indexing the data means we can create sparse indexes because the data is sorted. Those sparse indexes are actually living within the instance itself. So they're in memory. So we have data ordered on S3. You can stream in a petabyte of data and it will be sorted by this primary index. On the other hand, having the data ordered allows us to, for the first time, apply sparse indexing in memory close to the compute so we can prune data. And pruning data on S3 is everything. If you look at Athena or BigQuery or any other data warehouse, none of them will actually tackle the pruning problem as they should for many reasons. But pruning means I can download data that is actually what I need for the query. And when you run, and you mentioned before that, a lot of times when you work the lake, you need to think how you need to store data in the lake and how you need to place files in folders in partitions and do all of that. So you don't do that with Firebolt. With Firebolt, you just define your primary index and you let Firebolt handle the rest for you. Now, when you run your query on your terabyte or multi or petabyte scale, the query engine will use the sparse indexing to prune as much data as it can and eventually download during the query as less data as it can, which gives you this amazing, crazy performance boost on the first second you start using the product. So if do a copy paste of your SQL from another compute engine into Firebolt, the first thing you'll notice is the amount of gigabytes that were actually scanned for the query, which are between 1 and 2 orders of magnitude smaller than anything out there. So this is kind of the first problem, but it's not the only problem. This problem tackles big data. How do I enjoy S3, but don't have to download so much data from S3 just because I have 5 columns as predicates? So I want to do that efficiently. And this is kind of more in the big data domain. The second thing, which is pure computation, and I love this space because kind of this is where I started. This is where your query kernel, your query engine lives. And this is where you need to design it differently. So vectorization, LLVM, just-in-time compilation, encodings of data, applying superscalar decompression. All of that is needed because you want to run queries that are more BI-centric. So having a star schema is perfectly fine. You want to have a star schema because that's how you look at your business. Being limited by kind of big data platforms to force you into having this denormalized, highly flattened table doesn't make sense anymore as big data becomes just the new normal. So you want to have a system that can do big data stuff, yet you want it to feel like it's just a simple kind of BI supportive, star schema supportive database. So there are two universes here. And so the first one we talked about is storage and pruning and indexing and sparse indexing and sorting and merging in the background. But the second thing has nothing to do with it. It's all about in-memory computing and supporting joins and taking pretty much almost everything that was worked on in the academia over the last 4 years and trying to implement as much as possible into Firebolt. So this is kind of how we get our edge on speed. We tackle both sides of the problem, and therefore we can support both extreme use cases of self-serve versus kind of customer-facing high-velocity data platforms.
Today's episode of the Data Engineering Podcast is sponsored by Datadog, a SaaS-based monitoring and analytics platform for cloud-scale infrastructure, applications, logs, and more. Datadog uses machine learning-based algorithms to detect errors and anomalies across your entire stack, which reduces the time it takes to detect and address outages and helps promote collaboration between data engineering, operations, and the rest of the company. Go to dataengineeringpodcast.com/Datadog today to start your free 14-day trial. And if you start a trial and install Datadog's agent, they'll send you a free t-shirt. And can you dig a bit more into the underlying architecture of Firebolt? And I know that you have, as you mentioned, a proprietary file format in the form of F3 to be able to handle some of these sparse indexes and accelerating the range scans and reducing the amount of data that gets processed. Just wondering if you can dig through some of that and some of the ways that the overall design has evolved since you first began working on it and as you dug deeper into the problem.
Mm-hmm. So I try kind of to take us through the data journey, and maybe it will help to understand what's happening behind the scenes. So we always start with either a lake with files in it or some kind of streaming system. So it can be Kafka or it can be a set of kind of log generating tools, but those are our only two inputs. We support file formats, big data file formats sitting in the lake, S3, and Kafka / streaming platforms. This will be kind of how we start streaming data into Firebolt. When data gets streamed, there's kind of a micro process that's going on behind the scenes. So you need to launch a compute resource. Some call it warehouse, some call it engine, but basically it's a cluster of compute that has a local cache in it, and it executes your SQL. When you do an insert from your S3 bucket into a Firebolt table, you can create various types of tables, fact tables, dimension tables, all sorts of tables. But when you do that, we do a few things. We, of course, convert the raw format into our own format. We call those data chunks. The data chunk is a set of files. Unlike Parquet, we divide each column into its own separate file. This allows us more flexibility on modifying the data after you ingest it. So you don't need to process files, and you don't need to kind of go through expensive, batchy, long-running processes just because someone added a new column or just because someone wants to update the column. We want to have this kind of flexibility even though it's sitting on the lake. So the first thing is decoupling columns and storing them as different files. But this data chunk also has everything it needs to be self-descriptive. So the indexes that it has, the columns, the skipping indexes, the kind of encoding and compression that is applied per column. Everything is within the file, and everything is within kind of the file meta format sitting on the lake. The files are being generated all the time. The size of a file depends actually on the payload that was inserted into the database. So if I'm inserting one row every 10 minutes, then a file with one row will be generated. If I'm inserting 10 million rows every second, then we will generate a file with 10 million rows. So we will always try to commit the data as fast as possible because we want to provide real-time experience. This is kind of the beginning, but we all know that we cannot have those files stay as they are because they might be efficient for store, but not efficient for read. So files go through an evolution in which they start merge with other files as we ingest new data. And this merging process is one of the core and fundamental concepts of the architecture. It does so many things, from optimizing ordered files and converting them into fewer, bigger files, because our files are sorted. So it makes perfect sense to merge sorted files and enjoy ordering and compression. So we get much better compression than you would get from Parquet, just as a side effect from sorting. The second thing is that merging does other things as well. It does dedupe, it does upserts, it does slowly changing dimensions, it does anything that relates to data updates. And data updates with big data are a bit different than kind of traditional batchy updates. With big data, updates are happening all the time. Every day we're getting old data that we need to modify because that's how it is, slowly arriving data. So we've decided that aside from supporting kind of GDPR and old school batchy updates and deletes, we want to innovate on upserts and updates as well, and use the fact that we're so capable of merging efficiently that we will allow you to ingest data and do upserts throughout the stream without actually needing to apply kind of a batchy side operation to do that. So if you want to dedupe data, you just define a dedupe index on the table. If you want to update data, you just define how you want to update the data when new rows come in. So everything is kind of declarative within the table you define, and it's fit for real world big data versus trying to take old school snapshot, locky updates and apply them on big data. Now, there's another big thing, which is because data is in most data warehouses is stored in natural manner, natural order, then when you update stuff, you usually change much more than you actually need, because on the lake, data is immutable. So when you upload a file, you commit a new file, but you want to just change one row in it, you actually need to write the whole file. So people get confused. People get frustrated. People, they spend months designing their perfect Parquet kind of cluster structure, and then they just to kind of find out that every day they need to update data, and they end up rewriting 80% of the data. Now, when you order the data gets clustered in a much better way. So updating, the 10% that you usually need to update every day gets updated in a much more dense and clustered way. So it just, as a side effect, update much less data. Now, this is one thing, but there's another thing which is more complex, which is if you block the system when you update the data, then you ruin half of the potential value of the system. Because if updates are blocking, and if updates are long running, and if updates are expensive, then it breaks the real-time or near real-time experience on big data. So with Firebolt, we wanted to tackle that. And the way we did it is actually solving it on the query engine. And the way it works is like this. When you update something, we will version the files. We have an internal version mechanism that knows which file was updated and why. And the query engine, it knows how to compute on data even though it has duplicates in it. So dedupe, for example. Dedupe is constantly happening, but you don't want dedupe to block your system. You don't want to do dedupe in a batchy manner. You want dedupe to be just hidden behind the scenes and eventually merge it. So we move from low-key updates to eventual consistency via merging of data chunks. Now, eventual consistency is a problem because you can't work. And if you have eventual consistency on data, it removes a lot of critical use cases. Now, to get consistency, the query engine knows how to work with non-dedupe data. So even though you assigned dedupe on your table, you might have at a given point of time duplicates. Why? Because the merging process hasn't yet come to the point where it actually merges files, the specific files, and doing the dedupe. Because as I said, everything happens through the merge process. Now, so you find yourself on one hand having duplicate rows. On the other hand, you define your table to be deduped. So whenever you run your SQL, you want to automatically have your data warehouse solve the problem for you. And that's exactly what we're doing. We are decoupling the kind of eventual merging of files to apply dedupe from the ability of the query engine to still be able to work on duplicate data, yet give you the correct results. And this gets more complicated when you move to when you provide extensive SQL. So doing distinct count, doing mean, doing averages, doing aggregations that are not naturally you can't just append to. You need to have a stateful kind of aggregation mechanism. So I hope I got the data journey a bit clear. Let me just try to wrap it quickly. Data streams in from standard systems, gets converted, gets sorted, gets indexed. Those indexes are sparse. They will sit within the compute engine. And when you start working on that, pruning will make sure we download as less data as possible. And then the query engine will be responsible for the rest. Dedupe, upserts, and everything else is done by the merge process. It's eventually consistent, yet the query engine will always make sure you get consistent results, even though your lake might be behind and still have duplicate rows. Does it make sense? Did I explain it?
Yeah, that was definitely a very good explanation. And you answered my question before I even got the chance to ask it, as far as being able to handle eventual consistency and the accuracy of results, particularly in the case of things like duplicates, where you might run the report now as the data has already been merged and processed, but then you run it again an hour after more information has been added and some potential duplicate rows have been created, and then making sure that those analytics and the end user reports are consistent across those different spaces, just taking account for the new data and eliding the duplicates. So I think it's definitely interesting that you add that intelligence into the query engine to ensure that the eventual consistency of the underlying storage doesn't compromise the end user experience.
Exactly. For us, eventual consistency is more about what the user sees or the result of the SQL and not what's sitting within your lake. That's just storage. It's just like a temporary folder of files, but it shouldn't matter to the user. The user should get consistency. And to do that, we need to move eventual consistency from the storage to the querying part.
Another aspect of the problem that you're working through, beyond just the capability of storing the data efficiently and processing it efficiently, is being able to orchestrate the cloud resources that are being used to actually perform all these operations. And I know that another aspect of your value proposition is that you transparently pass through the underlying cloud costs to the end user rather than adding any sort of markup. And so I'm curious what your experience has been in terms of being able to handle the automation of those resources and trying to manage the efficiency of the overall compute and the infrastructure required there, as well as reducing the cost to the end user and some of the messaging and just the systems that are necessary to help support that aspect of the problem.
Okay, so two things. One is critical because when we thought about how we're going to sell the product and how we want to sell the product, we quickly realized that we have a core problem. As a company whose vision and mission in life is to provide efficiency and speed on data, charging per compute, per scan, per resource is just counterintuitive, and it's actually hurting our mission. And I'll explain why. This is coming from someone who's been building of been sitting on the other side of the river and building the technology that support your queries. And when you're a data warehouse vendor and you charge per compute, it's really you're selling resources. That's kind of that's your business. Your business is sell more resources because with today's data warehousing, resources are the only way to get speed. So the pitch is always the same. It's we give you fine-grained elasticity so you don't have to pay more, which is completely wrong. And I'll shortly explain why. But then again, you're kind of paying kind of a virtual credit, a virtual price that the data warehouse invented that hides the actual cost of what you're using. And if you are a company that relentlessly works on speed and efficiency, you end up one day asking yourself, am I hurting my business? If I'm going to release a new skipping index that does string search 100 times faster. Why? Because 6 months ago, someone from China released a new research article about it. And you look at it and you decide, okay, I love it. I want to try it out. I want to implement it. So someone will ask, okay, so what will happen to our revenue? I mean, if I'm making this SQL, which runs, an hour a night, now it runs in 5 minutes instead of an hour, then I'm hurting my revenue. So there is kind of a conflict, a inherent conflict when you want to provide speed and efficiency and you still charge per compute. So we've decided early on, even though we didn't know how to charge, we've decided we're not going to charge for resources. With Firebolt, we don't care whether you launch 1,000 engines, 1,000 nodes, or one. We will not make any revenue out of that. Now, to enable that, we used AWS kind of marketplace and tenant account concept. So as a customer, as an account owner in Firebolt, you will see each and every resource consumption on your AWS bill. And it will be with the price that you're paying for AWS, and it already actually supports spot instances or any other performance enhancing feature that AWS provides. And you will pay the cost that AWS charges you versus the virtual cost that we think you should pay for. Now, you may ask, okay, so how do we make money? I mean, if we allow people to do whatever they want with our product, which is true, how do we still make money? So the way we do it is we look at the feature set. So instead of selling compute or data scan or anything like that, we say, okay, so there's a big difference between someone who wants to have a customer-facing, production-ready, running thousands of concurrent users 24/7, than someone who wants to just replace Athena and get fast responses on his Tableau. So there's a big difference between someone who's using self-service BI and wants to work on granular data than someone who wants to embed analytics within their product. So we will charge based on features we use, and we divide that into subscription plans. So it's super simple. You have kind of a free version. The free version means that we don't make money. You only pay for electricity. You only pay for the resources that you actually consume, up to the second. So it's as fine-grained as AWS can be. If AWS tomorrow can go from a second to a nanosecond, so will we. The second thing is subscription. So standard is free. Then you have kind of the basic, which is I think up to a terabyte, and it goes kind of through a few levels. It's like buying a SaaS subscription, so like buying a Atlassian. It's as simple as that. Our goal is to get as many users as possible, to be a productivity tool on data, and we're less concerned on maximizing kind of resources or making money out of resources or more, or even kind of growing our revenue just because you as a customer gathered more data. I mean, it's ridiculous. I think it's a really big problem with data warehousing, and it's contradicting to speed and efficiency. Therefore, we've decided that we will not do that. We will decouple cost from compute, just as we decoupled storage from compute, and we'll have users pay a simple subscription price that is much, much, much more cost effective than anything they use today. And hopefully people will actually have their data warehouses running versus renting their data warehouse for an hour here or there, and actually kind of start using the data warehouse on more use cases, on more scale, and most importantly, without constantly thinking about how much a query will cost me. People ask before they ask today. We see it all the time. We see the way a typical POC goes like is you have an Excel file, you have 100 queries in it, and then you have kind of different vendors, different engines, different warehouses, different kind of t-shirt sizes, whatever you name it, and people kind of log the cost, and people try to manage who can run what because it costs so much. So this is kind of over. This is not going to happen with Firebolt, and users love it.
Yeah, it's definitely helpful to have that transparent cost because with Amazon in particular, it's virtually impossible to understand what you're going to pay when you first launch an instance. So just passing that through directly is, I think, useful because then the user doesn't have to worry about what additional costs they're going to incur, or with things like BigQuery where it's charged based on the amount of data that gets scanned and a sort of per query rate. It definitely, as you said, puts people in the situation of I'm only going to use this for what I absolutely have to versus allowing people to explore and experiment and unlock potentially, valuable insights that they might not otherwise achieve if they're just trying to reduce the amount of spend and just getting the bare minimum out of the query engine.
And exactly. And if you look at kind of how we build features on top of data, the typical person will tell, listen, if I need a new feature, it takes me a sprint. 2 weeks, it's done. But if I need a data-driven feature, it will take me 8 months. Why? Because I prototype it on one system, which is more cost effective and more suited for ad hoc exploration. But then when I want to take it to production, I discovered that I need to pretty much do it from scratch on different tool sets, different mindset, different new limitations. So it's super frustrating. And that's how we look at it. We think that someone who's building data-driven features, whether it's an engineer, a data scientist, or a business analyst, they should be able to move from exploration and experimentation to production extremely fast with the same platform. And we think it's extremely valuable for trimming down those 8 months and this frustration on building data-driven features.
And on the point of development, it also brings in the question of ecosystem support and what are the types of tools that somebody might use Firebolt to replace entirely, and what are the integration points for being able to embed Firebolt into their overall data platform?
So in terms of interoperability, we're doing 2 things. One is we have our JDBC driver, which should power Tableau, Sisense, Looker, and all the leading BI vendors. On your question to what do we replace, I would say from our experience so far, when it comes to internal analytics, it's mostly Redshift and Snowflake. When it comes to external analytics, it's mostly Athena, Elastic, and BigQuery. So those would be kind of the typical platforms we would tap into either side by side or replace. I mean, when you're a SaaS data warehouse and when you live in the cloud, it's much easier to move between systems. And we usually start sitting alongside those vendors, but quickly and hopefully people will start using more and more use cases on Firebolt because it's just more efficient. And it's a bummer to wait 10 minutes for a query to return when it should have returned in a few seconds. So I would say interoperability is mostly about providing the SQL support. By the way, we are derived from Postgres, so this is kind of our SQL standard. I'm talking about TPC, DS, TPCH level. We're going to release later this year the benchmark. So people who are interested in TPCH and TPCDS, stay tuned. New performance benchmarks are coming out, and you'll see new peaks on performance. Usually, we've seen that with GPUs. Now we'll see that running on commodity hardware. Again, when you work on sorted data, everything changes, even speed. So going further ahead, we're seeing stuff like DBT a lot. This is kind of super interesting. And we're thinking more and more about deeper integration with those modeling tools. Think LookerML, DBT, and there are a few others. We want people to be able to run those scripts completely within Firebolt, and we're working hard on doing that. So for a data warehouse, it's super important because you always tap into an existing ecosystem and you always have people running their Tableau dashboards and Looker live dashboards, and they don't want to rebuild everything. So part of the huge challenge with building a data warehouse is actually making sure that it won't take us 10 years to get to the interoperability that we want. So a lot of resources are put in advance to have as much interoperability as we can, to plug into as many existing environments as we can. And usually people don't build on top of Firebolt from scratch. They usually copy paste their SQL or they change connection in their Tableau. And this is how we look at it. I mean, Firebolt should be kind of a continuation of what we're doing with a much better experience versus if you want to get this speed, you need to rethink everything you're doing. So big no on rethinking and big yes on anti-frustration software, which it means being able to connect to existing stuff.
And you mentioned that you built off of Postgres in terms of the SQL support, which seems like a natural choice because of your ability to work with nested and semi-structured data. I'm curious what you have found to be necessary in terms of extensions or modifications to the SQL specification and the specific Postgres implementation as far as any additional built-in functions or extensions to the format for making it natural for people to work with large volumes of data.
Yeah, so yes, we started with Postgres as kind of the base to support BI, star schema, and more generic use cases. But then we implemented the Presto array manipulation dialect into our data warehouse because we believe deeply that people who write SQL will start writing array kind of a semi-structured SQL as well, because once they realize that how much they save and how more efficient they can become by doing that, then they just start doing that. So, when you look today, people flatten, people use window functions, people use all sorts of stuff. But if they had array manipulation baked into SQL, they would tackle problems differently to get kind of the speed and efficiency they need versus building an ELT process just because they can't do complex stuff on arrays. And when I say complex, I mean like doing multi-stage lambdas, anything we know from Presto arrays. This is kind of the first thing. So extending SQL to support semi-structured data, yet having it behave in a relational manner was the first kind of critical thing. The second thing is more about kind of managing and running your ELT. So SQL is our only language. This is kind of, you can do everything with SQL on Firebolt. And when I mean everything, it's not just DML, DDL, and select statement, but it's also resource management. You manage engines with SQL. So imagine that you have this ELT script. It can be, it's a multi-line, has a lots of stuff going on in there, but throughout the ELT script, which is purely in SQL, you want to modify resources. You're doing it in a big aggregation and you want to have a strong compute for that, but then you're moving to a simpler stuff and you want to change the compute. And you can do that in the script, interact, like when the script runs, it will modify resources dynamically to support that. So SQL is kind of growing beyond declarative selects and beyond basic operations on metadata and data. And you're now able to actually decide which resources you want to do your insert with. So you can have insert into a table and you say, okay, this ingestion is actually, I want to apply a specific engine on. By the way, I forgot to mention, with Firebolt, we have different types of engines. Why? Because it doesn't make sense to have one type of engines for ingest and analytics. For ingest, I would use a wider engine with many more nodes to maximize network bandwidth on S3. I want to download petabytes of data, so I want to have as much network bandwidth as I want. I also want to have much more local storage. But when it comes to analytics, shared memory is king. I want to have fewer nodes with more memory, more cores, because with high performance computing, we can do magic there. So when you kind of launch your resource, you decide what type of resources it is, not just the size of the resource. It can be an ingestion engine, it can be an analytics engine, it can be a generic engine. We're having an upcoming kind of real-time streaming engine that is different because this is more useful for real-time kind of high-frequency ingest use cases, which is different from sporadic up and down of I'm launching an engine to do some queries. So we have different hardware stitched together within the concept of engines, and this hardware is configured differently to support different use cases. So users can use SQL to change the actual resource they're using throughout the query, depending on kind of the phase of the query. And that's very powerful because you have one SQL that not only contains what you want to do, but also how you want to do it, what resource you want to apply. So SQL is being is growing beyond what we knew on traditional DBMSs and in traditional data warehousing, because now when you write SQL, you can actually control the resources you're using. Now, of course, when you allow people to control resources, you also need to give them the ability to control who can do what. So think about a quota system versus a just kind of old school user permission and security. With quotas, you can define which queries should consume what resource. You can define which users can do what. You can say, I want to have a maximum amount of money spent for this dashboard, for this user, for this use case. So we're really starting to see how people who actually work the data can be responsible for the resources that they operate on. So you don't have this centralized, cluttered place where people start to manage cost in Excel anymore, and you don't need to wait for permissions from someone to allow you to ask the question. The system is taking care of it, and the system is providing the new unique feature sets embedded within SQL to support it. So semi-structured and the ability to control resources would be the two big changes that we introduced into SQL.
And in your experience of building the Firebolt technology and the associated business, what have you found to be some of the most interesting or unexpected or challenging lessons learned in the process?
I've never worked at a place which is not a startup or my startup. I mean, so to me, it's kind of my whole career is feels like kind of the bullets you described. With Firebolt, though, it's a bit different because with Firebolt, it's the first time that we're building a company after we've built a unicorn before. So we've learned a lot with Sisense, and a lot of smart friends joined me to Firebolt with a lot of experience that we didn't have before. And when we look at Firebolt now, the speed in which we operate is completely different. So, with Sisense, we've raised a few $1 million when we started, and with Firebolt, we've raised an order of magnitude more money, and we have built an engineering team that we're so proud of. The engineering team is located, in 6 different countries. Building a data warehouse today means you need to have experts in storage, you need to have experts in cloud, you need to have experts in SaaS, you need to have experts in query engines. So there's so many different things you need to combine because it's a very complex system. And when you take complex systems and you want to simplify them for users, then it's just hard work, constant hard work, and ups and downs, and that's what I'm used to, and I love it, and I'll never stop doing that. So so Firebolt is unique because we are more mature and we are more focused, and we have a lot of experience, and we know what we want to solve. And when we started, we were 2-year-old, so the first year was pure research, and the second year was actually, starting the company in 2019 and hiring the 30 engineers, and which will double soon. So the company is 99% engineering today because we believe in, even specifically in our period, COVID, and everything that's happening, everything is self-served. Everything is, you don't kind of sell a data warehouse anymore. You sell a quick experience and you sell the solution to a problem. Everything is online. Everything needs to be SaaS. Everything needs to be instant. So it's very challenging, and but we love it, and we're looking forward to have Firebolt grow and tackle the problems that we think are relevant within our space.
So Firebolt is definitely a very impressive system and a complex feat of engineering, but what are the cases when it's the wrong choice and somebody should be looking to a different technical solution for their problem?
So there are many things we don't do well. I mean, we don't do most things well. We do data warehousing extremely well. So if you need an OLTP system to run your app, that's not us. If you need a key value store, even though we use key value store, we use Foundation DB extensively, we're not a key value store vendor. And there's so many amazing key value stores out there that productize it, their tech. So we're not that. We're a data warehouse, and we're a cloud native data warehouse. We cannot run on your on-premise environment. So if you're kind of a hybrid, if you need a hybrid solution, that's not us. Only do native cloud. So it means you need to have your data on S3 today. We're still on AWS, and we actually love AWS, and we think that until we get AWS, to perform perfectly, we're not going to move to other cloud vendors. We think that today and for the foreseeable future, AWS is where true big data exists versus kind of big data concepts. S3 is still the best big data storage environment. So we want to exploit anything that's unique about AWS and have that natively embedded within our product. So for us, it's not about supporting multiple cloud vendors. It's about supporting each in AWS first perfectly. So that's kind of what you need to run Firebolt. And this is why you wouldn't use Firebolt if you wouldn't have your data in AWS.
Are there any other aspects of the work that you're doing on Firebolt or the overall space of data warehouses and data lakes and storage engines, or the future direction that you're planning on taking, the technology and business that we didn't discuss that you'd like to cover before we close out the show?
I think we covered everything, almost everything, I think. Yeah, we did. I hope we did well.
Yeah, it was definitely interesting to learn more about the product. So I thank you for that. And for anybody who wants to get in touch with you and follow along with the work that you're doing or get in touch, I'll have you add your preferred contact information to the show notes. And as a final question, I would just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think that, so first, the data management ecosystem is doing well. So we're solving real problems and we're enabling amazing new products and amazing new experiences. So I think I have a lot of respect for a lot of vendors. And I think that given this slow changing environment where, it's just not easy to just, as I said, move from one thing to another, I think that things are not that bad yet. If you talk to people today, they feel like it should be that complex to operate. So people want to move forward. People want to focus on new challenges and want to provide new experiences with their offerings. If you look at how data is being built today, it's very limited. So most advanced companies have reached their limit in terms of what they can provide in their product given their existing tech. So with Firebolt, we're showing customers that they can move forward. They can do more and more interesting things on their products just because they have this new type of speed and efficiency that they never imagined they would have on the data warehouse. I think that the kind of historically, even though I complimented the market, I think that the market is yet over complex, and it was doing well because uber smart people operated it. But if you want to open big data, if you want to have more people involved, you need to simplify it because most people are not engineers and most people just want answers. And to enable them, we need to have fewer tools. We need to have more consolidated environments. And I think that's where the market goes. I think that over the next 5 to 10 years, we'll see less interoperability on the stack. I mean, ecosystem will always exist. So ELT tools and BI, they will always be there. But on the kind of the data warehouse stack, on the data lake stack, people will start using few vendors and will start using fewer products and will, favor products that do more for less versus products that talk about scale and just in lakes. So I think the market is moving from the tech and how to what we want to do. And we'll see more companies and products coming out that simplify it and hide the complexity so people can move faster.
Yeah, I definitely agree that the simplification is the step that's needed now and something that is definitely proceeding with a number of different companies. So I appreciate your insights there. And I thank you for the time that you took today to join me and discuss the work that you're doing with Firebolt. So I appreciate all the time and effort you've put into helping to move the industry forward and simplify the experience of users trying to work with large volumes of data. So thank you again, and I hope you enjoy the rest of your day.
Thank you for having me, and enjoy the rest of the day as well. And good luck to us all with data.
Thank you for listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.